The following content has been provided by RWTH Aachen University.
Okay, so the last couple minutes I want to use, since we've now sort of completed almost all the different test mechanisms, I want to dig into a little more detail on one specific method that is a model-based evaluation. Remember, we had, without users, we were talking about model-based evaluation as the fourth form, and there was a particular technique that I wanted to talk about in more detail. That's why we didn't cover it in there, because otherwise this would have stretched out for a long time. And that technique, I want to start with this little story. So you guys might know this person. This is Jakob Nielsen. He's a now famous web guru. So he's very well known for his alert box column. Look it up online. It's a lot of fun. It gives you design advice for online media, very, very practical and hands-on. And back in '95, so like ages ago, he was given a task. He was working at Sun at the time, and he was given a task to give recommendations about whether Sun should add 3 new buttons to their homepage. The problem was he had less than 24 hours to do that. So in that time, you can't run and recruit users for a study and all that kind of stuff. He was able to give an answer, and he found out that each new button that remained essentially unused, because it was something that people weren't very interested in to go to right from the homepage, would cost the visitors in total about $500,000 per year. As a result of that, 2 of the 3 buttons that were supposed to be added to the homepage of Sun Microsystems back then were taken back out before the release of the website. And the method he used to do this monetary estimate of $500,000 is called GOMS. And GOMS is the technique I want to talk to you guys about for a couple more minutes now. GOMS is an old method. It's been around actually as long as this book here. And you guys should recognize the names of the authors, at least one of them, Card, Moore, and Newell. Does that ring a bell? CMN, yeah, the CMN model, right? Those are the guys. They published the model in that book. And GOMS is another one that is also published in this book as a technique to evaluate the basic execution time for a system. And the cool thing about this is you can actually estimate the execution times and also learning times in some variants of GOMS before the system is actually built. You don't need a working prototype that you run a user study with in order to find out how long people are probably going to take to operate it. That's pretty cool. And that's how GOMS, the way GOMS does that is that it models the interface in a mathematical way, if you like, and then lets you compute the execution times and, like I said, sometimes learning times. GOMS, the name is fantastic. I think it was made for students because the name already includes the first letters to the 4 important components of the model. G as in goal, O as in operators, M as in methods, and S as in selection rules. So that's what GOMS stands for. Goals are end-user goals, kind of like what we know from the 7 stages of action. There are, however, and this is important about GOMS, there are always going to be routine tasks. So not let me write a novel, because that's a highly creative task where it's not predictable how long that's going to take you, really. They have to be routine tasks that you can do just as fast as you physically can. You're not stopping and thinking and scratching your head for very long anywhere. So more things like, I've got a manuscript, I've got a text, and somebody marked up some mistakes, some typos in there, and I now need to go in and fix those typos, right? So I'm going to go back between this original and my new text here, and I'm fixing the typos. the goals that we find in GOMS will be decomposed into a hierarchy, a tree, essentially, as a data structure, if you want, of sub-goals. So it gets taken apart, kind of like the 7 stages of action take a goal and break it down into action sequences. This breakdown keeps going on from goal to sub-goal to sub-sub-goal, etc., until at the very bottom, at the leaves of the tree, basically, you have what's called operators. Operators are elementary actions, physical things you do that you can associate an average execution time with. Examples would be pressing a key, or selecting a menu item, or maybe dragging, dropping something in a GUI, or reading a dialog message that pops up, or a simple gesture in a gesture-based interface, or a speech command. So the important thing is that these elementary actions, these operators, can be assigned a duration that is independent of the concrete context when it's happening. It's always the same average. So a key press in using the system takes that many seconds. Methods are procedures to get to a goal. So when you have a goal and you say, in order to reach that goal, I need to do the following 15 steps, then that would be formulated as a method. And each of these steps in the method would break down into sub-methods, like sub-procedures, or would lead directly to an operator with an associated time. And then finally, sometimes there are different ways to solve a goal. My favorite example is delete some text. You could press delete, 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 delete if you just want to get rid of a couple characters, or you could press, maybe use the mouse to double-click a word and then press the delete key once if it's a longer word, or if you have more, then you maybe click, drag, select a whole block of text, and then press the delete key to get rid of it. And which of these methods you use to reach a goal or sub-goal will be modeled in a selection rule. So we then say 20% of the time people will probably be using this method, and 80% of the time they will be using this other method. In this case, the branches below that goal, and as a node in this tree, will be branches that are taken one or the other, in a particular mix. 20% of the time this one branch, 80% this other branch. So here's an example. This is a sample goal called highlight arbitrary text, and it's kind of special because it only consists of elementary operators. We don't have any sub-goals anymore. This is already broken down to the very basic. How do you highlight some arbitrary text in a document? Imagine yourself sitting in front of Word and you're trying to highlight some text. Well, in the system here described here, you would move the cursor to the beginning, you would click a mouse button, you would move the cursor to the end, then shift-click the mouse button, and then verify the highlight. So this is not using a click-drag operation, but it's using an operation where you position the cursor and then click, and then you position the cursor again and you shift-click, and that's your selection. You probably use this when you use Windows Explorer to select a couple files in a directory, right, in a folder. And the last part here is verifying that you highlighted the right parts. So this is broken down into 4 elementary physical actions that you do, and 1 mental action that you do to make sure that you did the right thing. And these times here might be surprising, because we've actually associated fixed times to these actions here, although we don't know how big the selection was. Have you guys learned a rule recently in an interesting class that could tell you about execution times for clicking targets?
Fitts law.
Fitts law, yeah, exactly. So this is more of a rough estimate than Fitts law. Fitts law looks at the actual distance to the target and computes the expected time to do this. This GOMS model here just makes an average. It says, yeah, there's going to be small distances and large distances, but it's all going to even out in the end. And we've tested this and measured this, and we found that in practice, on average, a selection of text in order to move the cursor to some position on the screen takes 1.1 seconds. Then to click a mouse button takes 0.2. Then moving the cursor to the end is the exact 1.1 seconds again, because that's the average time of moving the cursor to a target on the screen over all different distances and positions. You shift-click then, that means pressing a key and clicking. That's a little longer here, as you can see. And then we verify, and that on average, it's also been determined experimentally. You stop for about 1.3 seconds to make sure that you selected the right thing before you move on and do the next thing.
This content was provided by RWTH Aachen University.